Haha, welcome back. We are obviously we're moving on to lesson number 3, talking about angles. And before we do too much new stuff, I want to just briefly talk about a little bit of review. Looked at some of your worksheets, most of your worksheets yesterday, and some people are making some common mistakes. So I want to address those issues before we move on. Most people are pretty good with complementary angles. When you see a right angle, you know that it's going to be 90 degrees. So these have to add up to 90. Pretty basic stuff. That one is pretty good with most of you. Most of you are decent at supplementary angles. Any straight line, right, is 180 degrees. So you can have another angle on this line, and this would be another 180 degrees. So make sure that you're okay with that. Now, in this situation, and this is where some people are messing up, we're putting an angle that looks like it's clearly less than 90 degrees, because 90 degrees would be straight up, and we're putting a number that's way bigger than it could be possible. So if your number is bigger than 90, like if you know that 90 is basically going to be a right angle, and your number is 100 and it's a small angle, then we've got issues. Common sense says that that can't be 100. And we've probably messed that up. So if your angle is small, it can't be a giant number in here. It has to be less than 90, because 90 would be this angle. So this would have to be, logically somewhere around 50 degrees or 40 degrees. That would make sense. Again, this is going to be 180 degrees, so that's just going to be 105 degrees. So just the logical part, some people are messing up. And some people are also messing up these opposite angles. So if they're 50 degrees here, remember that right across from the intersection has got to be a twin. It's got to be 50 degrees. And then once you have that, you can find a straight line here, which is this red line. And these two must make 180. So 180 take away 50. This one's got to be 130 degrees, which means across from it has got to be exactly 130 degrees. These two are twins. So don't forget that. Anytime you have an intersection, those are twins and those are twins. And they all add up to 360 degrees. And two of them beside each other add up to 180 degrees. All right, perpendicular lines, no big deal. Everybody knows that they're 90 degrees. That's a little symbol that means perpendicular. Parallel lines, I think everyone's really good with that. Remember that something called a corresponding angle, that those are equal. And they're in the same spot in a different location. So I'm not going to spend too much time with that. The terminology we talked about last day, corresponding means same spot, different intersection. So those would be corresponding to each other. An alternate angle or alternate interior angle is on the inside, and it makes a Z shape. So if you see a Z shape like that, then those angles are equal. The Z shape, I forgot to, well, I didn't forget, but it has to include the parallel lines in your Z. It has to use both parallel lines in the Z. Likewise, you can make a Z in the other direction. It could be a backwards or a forward Z, doesn't matter, but that makes equal angles there. And the blue angles are only equal to each other, and the red angles are equal to each other. The blue ones do not equal the red ones. Finally, co-interior angles. Co starts with the letter C. And it's easy to remember. It makes the C shape, either a backward C like that. Those two angles, they're not equal, but they add to 180 degrees. And on the other side of the C as well, if it's a forwards kind of C, it has to use both parallel lines again. Those two blue ones add up to 180 degrees, and they're called co-interior angles. So they're supplementary because they add to 180. All right, new terminology for today, congruent angles. Congruent is just a big fancy word that means that they are equal or the same size, the same amount of degrees. So these two angles here are congruent because they're both 110 degrees One is upside down, doesn't really matter, it's still the same size, so it's considered congruent. Adjacent is the other word. Adjacent is, again, a fancy word that just means that they are right beside each other. So as you can see in this diagram here, two angles, they actually share one of the rays. This center ray is shared between both angles, and they are directly beside each other. So those are called adjacent, if you're right beside. And third today is something called a reflex angle. A reflex is the angle on the other side of the lines. So here we've got 130 degrees inside the angle, which is what we've been talking about. But on the outside of the angle, we can find the measure of that. And notice it's a real big angle, right? If this was right side up, it would be kind of like this giant angle from here to here. It's bigger than 180 degrees because 180 degrees would extend from here to here. So the adjacent, or not the adjacent, the reflex angle in this case is easy to find. We take 360. Most of you know that it's 360 degrees all the way around a complete circle, right? If you stood in facing one direction and did 360 degrees, you do a complete circle and face the same direction that you started in. If you did a 180 degree circle, it would be only halfway around, you'd be facing in the opposite direction. So we take 360 degrees and we subtract the amount that we know, which in this case is 130. So 360 minus 130, just do the old arithmetic, and that leaves you with 230 degrees is the reflex angle. That's from there all the way around to here. Remember that this one plus this one has to make 360 degrees. So if you're given a reflex angle, you can find the inside angle, the small angle, the same exact way. 360, in this case, minus 260. Those are both degrees. Don't forget your cute little degree sign. And that leaves you with 100 degrees on the inside. And remember, logically, this almost looks like a right angle. A right angle would, I don't know, maybe be like that. So it does make sense that this is a little bit smaller. Sorry, a little bit bigger than a right angle. So 100 degrees does look logical. It wouldn't make sense if you had like 40 degrees in there, because a 40-degree angle is quite small. All right, other stuff that we have talked about before, but I want to stress today is that inside of a triangle, all of the angles add up to 180 degrees. So when I add all three of those, I get 180 every single time. So if I've got this triangle here, and I'm given two of the angles are 70 and 60, if I add 70 plus 60 together, that's 130. The entire triangle is 180. So if I subtracted 130 from 180, that would leave me with 50 degrees as the top angle, because it has to add to 180. If you've ever seen an equilateral triangle that's got three equal sides, but more importantly for us, it's got three equal angles. So all of these angles are going to be equal. And you can figure out what they are by taking 180 and dividing it by 3, because they're all the same, and it goes in exactly 60 times. So each of these angles has to be 60 degrees, because it's an equilateral triangle. All right, now can we use some of this to solve some more complex questions? So these are similar questions to last chapter or last lesson, except a little bit more difficult. And I know most of you are saying, yes, we want more difficulty because that other stuff is too easy. So when I get to a question like this, there's a couple things that I want to recognize. First off, there's arrowheads here. They're small, but don't forget that they are really, really important because they tell you that you've got a bunch of corresponding angles that are going to be equal. Now, when I have a question like this, I always start off with the easiest stuff. And for me, the easiest stuff is an opposite angle right across the X, right across the intersection. So these two are gimmies. It's like a free mark on a test. Okay, now once I have those two, I'm going to look for straight lines. So I got a straight line right here. So this one and this one have to make 180. That means that this one has to be 60. And this one also has to be 60. Now we've got the exact intersection up here. right? They're all corresponding angles, so that's got to be the same. They're all 120s and 60s. 120, 120, 60, 60. Now remember, if you mess it up and you put 120 here, that does not look like a 120-degree angle because that's a small angle. It's less than 90, so it doesn't look right. Logic tells me that something is wrong there, so make sure that they make sense. The 120 has to be the big angle, and this is the big angle. All right, so far so good. Where would we go next? Well, we've got a straight line here. And these two have to be 180 degrees, and one of them is 85, so that means that this one's got to be 95. 180, take away 85. And the opposite one is also 95 degrees. Now, here's where our triangle rule comes in. Because we've got a triangle here, we can use the 180-degree triangle and subtract the 60 and the 85. So I'd add 85 and 60 together. That's 145. And then I would subtract that from 180. That leaves us with not 100, with 35 degrees. So this angle has got to be 35 degrees. Let's get rid of that little dude. And now we're away. As soon as we know that that's 35, we know opposite that is 35. And we know that these guys are 35 because they're corresponding down here. Same exact corner in a different intersection. And once we know that those are 35, these got to be the other numbers, supplementary ones, 145 and 145. They're opposite each other, and 145 and 145. So there we have it. Don't want to forget those little signs. We've got pretty much everything here. Not too difficult. Uses the triangles. Same thing here. We've got triangles. I'm not going to do every single question here, but not every single angle. But again, I would start with the easy ones. They're exactly across from each other, so let's put those in first. If this is 110, and this makes a straight line, then this one's got to be 70. And remember, it looks like it's 70 because it's smaller than 90. This one's got to be 70, and then we can find the bottom here because 70 plus 32 is 102, and if I subtract that from 180, that leaves us with 78 degrees. This one is 78. In fact, we could also find this, the reflex angle, because that would be 360 minus 78. So, not too bad. All the rest of them are pretty simple. I think you could figure those out with all the skills that you know. That leaves you with 282, by the way. That's doable, not that difficult. This one runs into some problems. Let's run through some of these together before you try your own sheet. So again, start off with the easy ones. That's a gimme, 90 and 90. 90 and 90 up here. 76 across from there, and 60 across from there. Those are basic. 180, a straight line, take away 76, that leaves us with 104 and 104. That means that this is 104 and 104. That means that this is 76, this is 76. And look at that, we've got two angles inside of a triangle. That means we just add those together, that's 136. And I take 180 minus 136, that leaves us with 44 degrees. So this top of the triangle is 44. Now this one has to be 120 because it makes a straight line, and 120. Again, it makes a straight line right here. So that one and that one make 180. This one up here is 60, we know that. And this one is 76 because it has to be because of these arrowheads. This one and this one have to be the same, and they're the same as this one because this has an arrowhead as well. All right, pretty basic. 76 is over here. And this back one here, because this is across, these two have to add up to this one. So that looks like it's 60 and 44, 104. You could have also said, hey, that makes a straight line right there, so 104 and 76 must make 180. So it's all doable. Just use the skills, remember the triangle parts, and remember the parallel lines and stuff you did. So try today's worksheet. Good luck with that. Let me know if you have any issues.